For a long time, the world of math was, well, basically one long single road, a number line. But what if we could break free from that? What if we could build a full-blown map, a world where every single point has its own unique address? Well, today, that's exactly what we're going to do. I mean, really think about that. Imagine your entire world was just one long street. Giving an address would be simple, right? Hey, I live at house number 5. But that's so limited. What if you want to go off-road? What about the space around the road? See, we need a much more powerful system. And today, we're going to build it from the ground up. So our journey starts by crossing a familiar landmark, the number 0. We're about to explore the territory on the other side. And in doing so, we're pretty much going to double the size of our known mathematical world. It's funny, we take negative numbers for granted, but they represent a huge leap forward. It's like discovering a brand new continent just on the other side of an ocean you thought was the edge of the world. This isn't just about counting down, it's about introducing these really crucial concepts of direction and opposition. And these new inhabitants of our expanded world, they have a name: integers. The idea is actually beautifully simple. For every positive number, there's a perfectly balanced opposite negative number on the other side of 0. They're like perfect mirror images of each other. So this right here, this is the fundamental rule of our new world. Just think of positive as a command, move right or move up, and negative is the exact opposite command, move left or move down. These two simple ideas, they're the building blocks for absolutely everything that comes next. Okay, so now that we have all these new numbers, how do they all fit together? There's a fantastic analogy for this. Think of them like a set of those Russian nesting dolls. At the very core, you've got the smallest doll. These are the whole numbers. You know, the classic, straightforward counting numbers you learned way back when, starting with 0. They're simple, they're clean, no fractions, no negatives, just the basics. All right, now you take that first little doll and you fit it inside a slightly bigger one. This is our set of integers. It has all of the whole numbers inside it, plus all of their negative opposites. So just like that, our number system got a whole lot bigger. And the final, biggest doll in the set? Those are the rational numbers. This doll holds all the integers, plus all the numbers that live in between them. Yep, every single fraction and decimal you can think of. It's the most inclusive set we've got so far. So we've expanded our number line, we've organized all of our numbers into this cool nesting doll system. Now it's time for the main event. It is time to break out of that single dimension and create our map. This is the moment of creation right here. We take one of our number lines, that single row we started with, and we lay another one right on top of it, but perfectly vertical, at a right angle. One running left to right, the other running up and down. So what do you get? You get this. This is the coordinate plane. That horizontal line, we call that the x-axis. And the vertical one is the y-axis. And that spot right in the middle where they both meet at 0, we call that the origin. It's the heart of our entire map. So now that we've drawn our map, you'll probably notice it's naturally divided into 4 distinct regions, like 4 different neighborhoods or territories. We call these sections quadrants, and there's a really clever trick for remembering their order. Just draw a big letter C with your finger starting from the top right. That path literally takes you through quadrant 1, then 2, then 3, and finally 4. Super easy. And here it is, the ultimate cheat sheet for our map. But notice the logic here. It flows directly from what we just learned about direction. For example, to get to quadrant I, you have to move right and up, so both your coordinates are positive. To get to quadrant 2, you move left and up, so that gives you a negative x and a positive y. See? This simple pattern holds true for all 4 quadrants. It just makes sense. Okay, the map is drawn, the territories are labeled. Now let's solve our original problem. How do we give a precise address to any single point on this map? We do this with something called an ordered pair, and we write it like this: x, y. Now that word ordered is absolutely crucial. The first number always tells you how far to go left or right along the x-axis, and the second number always tells you how far to go up or down on the y-axis. The order matters, big time. So let's try one together. Say we want to find the address -3, 4. We always start at the origin, right there at 0, 0. The first number, the x-coordinate, is -3, so we move left 3 spaces. Now, from there, we look at the y-coordinate, which is 4. So we move up 4 spaces. And boom, we mark the spot. That is our exact location. Here is a simple, really memorable way to think about it. The x-axis is like the hallway. You have to walk to the elevator first. Then the y-axis is the elevator itself. You ride it up or down. You walk, then you ride. X first, then Y, always. And that, right there, is the whole breakthrough. We have gone from a world with just one road to a sprawling city where every single point has the precise, unique address. And this isn't just some abstract idea. This is the foundation for everything from your GPS navigation to the graphics in video games. We can now describe a location in a way that was completely impossible on just a single line. This whole system is perfect for a flat 2D world, like a piece of paper. But that leaves us with a final and pretty fascinating question. How would we map our own 3D world? I mean, what would a third axis, one for depth, even look like? And where would it go? Something to think about.